Okay, so what I want to do is continue on the discussion that I had a few weeks ago on these Cretaceous inliers in north central Oregon. And what I'm doing is trying to find out whether there's any information in the source rock data that would point towards the hotspot passing under this part of Oregon. As remember, back in the earlier talk, Siletzia rammed into the North American plate in the Eocene time, and then the North American plate proceeded to move westward over the hotspot, and the hotspot ended up in Yellowstone. And so here is the location of the Cretaceous inliers in Oregon, and the hotspot supposedly passed through this area sometime in the Miocene. So this obviously is going to be after the Cretaceous inliers have been deposited. So again, this is the location of the inlier belt relative to Oregon and Washington, and all the other gas and oil indications that we talked about before. So what I did was I went back into the reference that Montgomery gave in his report on Seidel and Richards that was published in the APG in 1985. And they went into this in some detail. And then I also looked up a number of other references that also bared on this topic. So here's the Mitchell inlier relative to the John Day inlier. These are the Cretaceous inliers relative to the Idaho batholith. So here's the map of Seidel and Richards, and you can see that they were able to map the organic carbon content 0.5%, 1%, and 2% based on the data that they collected. They also showed this oil and gas line, and it's curious to me why they did this, but it's based on the peak Tmax in Rocky Val, whereas values between 435 and 470 are considered oil prone, and those above 470 are gas prone, which seems to me isn't very good, because the gas prone source rocks had to pass through the oil window and could have obviously given off oil at that time as well. So here's an enlarged map of the area showing the sample locations. The outcrop built in a little more detail. And when I did this, I noticed that the third sample shown at the very bottom of the map was missing. And when I looked at that outcrop in detail, there was a small dot that I thought looked like the place where this third sample would be. And this data from that sort of fits in pretty well with what we're looking at in terms of the data. So here's a stratigraphic section of the Cretaceous inlier showing the Gable Creek and Hudspeth formations that get up to over 9,000 feet thick in total. It's a sequenced stratigraphy package. The Hudspeth is the source rock, and the reservoir rock is considered the Gable Creek, even though there are some sands within the Hudspeth. What they were able to sample was an oil show in a geode in the overlying group in the Clarno. And there they took this oil sample and ran a GC on it, and I'll show it in a little bit later. As you can see on the right, the Hudspeth formation, the base of it is essentially transgressive from the southwest to the northeast, whereas the tongues of the Gable Creek pushed to the southwest in a regressive manner out into the shallow marine interval. And overlying that is the Clarno, which is broken into two groups, one 4,000 feet thick and the other two or thereabouts. And they're basically andesitic flows in the lower, along with mud flows and lacustrine rocks and tufaceous sediments in the upper unit. Overlying that is the John Day, which is mostly a non-marine unit of tuffs and fluvial deposits. And then overlying that is less than 1,000 feet of Columbia River basalts, which covers much of the area. I call that the regional section because that is overlying the Cretaceous inlier. Here is a time stratigraphic chart of the Hudspeth and Gable Creek. You can see at the base is the transgressive unit going from southwest to northeast. And this is where the richest source rock was deposited. And this is the type 2/3 group A source rock that was deposited. Overlying that is the regressive unit where the Gable Creek pushes out into the thing from non-marine into fluvial and marine depositional environments. The rock units of the Gable Creek shown on this QFL diagram, quartz, lithic, and feldspar, show that the Gable Creek sands are lithic rich. But when the regressive packages push out into the shallow marine and the Hudspeth has this Hudspeth sands obviously were reworked and the lithic material was winnowed out or destroyed, and you end up with a more quartz-rich reservoir rock, which was pretty good in what you might expect. This is the chromatogram of the oil that filled the geode in the Clarno group. So we know that the oil was generated, we know it was expelled into the overlying unit, and obviously the unit had to be there, so there was some burial that generated the source rock, or excuse me, that generated oil from the source rock. You can see the high pristine phytane ratio, which is indicative of an oxic environment. The baseline of this chromatogram is pretty flat, which indicates that there really are no complex biomarkers. And to me, what's also very remarkable is the fact that this oil is unbiodegraded. It looks pretty fresh. So I consider this a high API gravity oil, probably and expelled from a type 2/3 kerogen that you will see comes from the lower part of the Hudspeth. If we go back to the map that Seidel and Richards published, the 2% line is really where the good source rock is. And for the most part, these are the least mature source rocks. As you move down to and more leaner rocks, there's just what he considers the gas-prone source rocks, where they had a high Tmax value. And you'll notice at the bottom under the CO6, there is no CO3 down near the H in Hudspeth at the south end of the map. And that's the sample that seems to be missing, or is missing. So when I looked at this data on a modified Van Crevelen diagram and compared it to the previous map, I noticed that samples 2, 3, 4, 3, 4, 5, and 6 were all above 0.5% TOC. So that contour line of 0.5% is improperly placed, and it really is a 1% TOC. And there is one TOC value that gets over 3%. So there really is a 3% value as well. When you plot this on the modified Van Crevelen diagram, this is the HI, which is not shown here. You can see that there are two groups, Group A, which is oil prone, and Group B, which is gas prone. And the oil prone group is the transgressive samples, and the B are the regressive samples. And here is the same data, and I've included here the location of sample 3. When I re-plotted all the data seems to concur with what Seidel and Richards showed, except that the contour should be 1%, and the 2% is the good source rock again. And then up near the 3% at the very top, just left of Mitchell, you can see an oil stain. And this is very interesting to me. It's right in the middle of, or essentially in a very, shall we say, strategic location when we look at it later. So here's a complete sample list. I expanded the table to include all the C15 plus data. And the sample 7 has very, very high extract, which indicates to me it's an oil stain. And I can't figure out why they didn't run a GC on this data, or on this extract, but they didn't. And otherwise, the rest of the extracts are quite low. And attached also is the hydrogen index and the oxygen index data that was plotted. When you plot this out in group A and group B, samples 1 through 5 and 14 through 16 are in group B, which is the gas prone data, and group 1 or group A is the oil prone, just as it was plotted by the authors. What was interesting for me was that the A group, the oil prone group, is all plotting in the same place except for one sample, A6, which is the oil prone group, but it is farthest to the southeast, which you will see in a moment is one of the higher thermal maturity datas. Again, I show the modified Van Crevelen diagram with the same data points, but this time I plotted the T max values with it to show that the lowest value, 412 degrees, the immature one, is got an HI of just over 400. And as you move down the sample, the T maxes do increase. There are some exceptions, but generally speaking, the data follows the evolution line of the kerogen. Group B is the same. All of those T maxes are very high, and what you would expect of a thermally mature source rock, but they do plot along the type 3 kerogen line, indicating a gas-prone kerogen. I also plotted the data in the two groups. Group A against the TOC and the S2 peak, showing that the slope of the line indicates an HI of around 350. And then the group B, which has some refractory carbon that's between 0 and 0.5, but it also has a slope which is quite low, of HI of 160, indicating that it's a gas-prone source rock. Again, when you look at the HI map, and you try and contour it, you really can't. The data is all over the board, and so it's just a map with no trends. However, when you plot the Tmax, the values run from 435 up near Mitchell, right near the oil stain where the thermally immature source rock is. And as you move to the southeast, the values get up over 480 or up into the oil gas prone area, or the gas evolution area for a source rock being mature. And then going to the northwest, the values also get very high. So one of the things that interests me was what would you do when you plot these things based on Tmax? And surprisingly enough, there is a rhythmic burial going from the greatest burial to the southeast, a peak where it's immature, right where the oil stain is. And then as you move north, you see that the Tmax gets quite high again. When you look at the map above, you can the Blue Mountain anticline is shown to run through this area. I don't know if it has anything to do with this thermal maturity, but it seems to me like the burial is greatest to the north of the oil stain and to the south of the oil stain, and that the focal point of migration should be towards the Mitchell area. So here's a quadrangle map, the Mitchell quad, and there are three cross sections that Oles and Englos published in 1971. And cross section AA prime in the northeast shows the anticline. It's for the most part breached, but it is real. And so the thermal maturity map, or the thermal maturity data, for some reason or logically reflects this anticline. So when we look at the overburden rock, this is the thickness of the Clarno. It gets up to 6,000 feet, and you can see in the Mitchell area, there's a lot of volcanic vents and the location of the inlier, which surprises me that if these volcanic vents are real, why they didn't thermally mature this source rock to an overcooked nature. That in itself, but it didn't do that, and obviously the hotspot didn't overprint it either. So here's the John Day Formation. It's been eroded in many areas, but the Mitchell area right there in the middle is shown again. And, and then the last section is the Columbia River basalt, which is not quite 1,000 feet thick. And it's also an overlying unit that could substantially or could possibly bury the Hudspeth source rock. You can see from this block diagram, there is a real unconformity between the Maskell Formation and the Columbia River basalt. The Gable Creek conglomerate is shown on the right. And according to this block diagram, the Clarno Formation does not really get to a maximum burial depth over the source rock. The John Day looks like it might. And then, of course, some of the basalt. So when I put together the events chart, parts of it are easy, and the other parts are pure speculation and would require a lot more work. But the Hudspeth is at the base, to me, is the transgressive source rock, no question there. The Gable Creek is reservoir rock, along with the basal part of the Clarno. And the overburden rock will go from the Hudspeth, the base of the Hudspeth, and that's got at least 9,000 feet. You have a few feet of the Clarno, some John Day, and then the Gable, then the Columbia River basalt. Seems to me that the trap formation is probably sometime in the Clarno time, which is Eocene, and generation migration probably occurred about then, along with the critical moment. So when I look at this with respect to what is going on in this Cretaceous inlier, the oil composition to me is coming from a terrigenous rich type 2-3 source rock, that the composition indicates a high gravity oil, say 35 or higher, that the group A during the transgression is for the most part the oil source rock. And based on the HI and the OI data, Group B is an oil-prone source rock, regardless of its thermal maturity. And the burial history of Group A is probably reached its maximal burial sometime during the Clarno or maybe even the John Day, well before the hotspot passed under the area, which would be in Miocene time. And that would be the time of the basalt deposits. So my working hypothesis for this area is that the Cretaceous source rock was totally unaffected by the hotspot because the thermal maturity can be accounted for by the overburden rock. And the hotspot, if it did go through and have a big effect, it probably would have burned the source rock up completely, but it didn't. And so to me, that's an indication that I better look somewhere else for evidence that the hotspot actually passed through this area. So thanks for your attention. And if anybody has any questions, I'd be happy to answer them. It's a little different than the geophysical discussion.
Yeah, Les, this is Alan. So the question I have is, how do you determine what the source rock was when it was immature based on only having partially mature source rocks if you don't have an independent measurement of vitrinary reflectance or something? I presume, but maybe I'm wrong, that your correlation between Tmax and vitrinary reflectance was just something out of the literature, not not two separate measurements.
Yeah, these guys didn't do, Seidel and Richards didn't do any vitrinite reflectance that they reported. So there's no way of doing it. But I would have thought that the type 3 Kerogen would have given them some good vitrinite data, because there's a lot of debris coming from the continent, plant debris and all that. So they should have gotten good data in both units had they tried to get it.
Les, it's Ken.
Oh, you're there, Ken.
Yeah, I'm here. You showed one slide where you talked about volcanic vents, and you said you didn't show any evidence that there was maturation of the organic matter around those vents. What kind of vents are those? Are those hydrothermal vents? Are they volcanic plugs? What is this a very localized thing or what?
Well, they're andesitic. So my guess is that these are highly explosive volcanics that are and they have these cinder cones, or these cones that are mappable. I don't know how much I don't know how much regional heat is involved with those, but since the source rock didn't seem to be impacted by them, it doesn't seem like they're being the cause of the source rock maturation. I wish I knew, but when I started looking in this and saw all these vents, I thought, and this is at the same time Silesia was being rammed against the continent to the west, and something is causing the heat to create all of these volcanoes. So it's kind of an enigma for me as well.
Yeah, it's strange. I suppose if these were just sort of very localized, there's a lot of them though. It suggests there might be a big Pluton down there somewhere, but and you'd expect regional metamorphism, but it may be that just these are very localized and there were explosive vents that the heating event was very transient. I don't know.
Yeah, I agree with you. I mean, these are andesitic, and so I mean that they're at the other end of the spectrum with respect to basaltic, so they're not flows. They create these composite cones that are quite steep-sided, and they're more they're not mafic. They're more aphanitic, or they're more leucocratic, I should say. They're the light-colored volcanic material. So that's one of the things I've been trying to get a little handle on, that with respect to the Klarno. The Klarno has a lot of fossils in it. It's got nut beds and all kinds of fossils. So the country couldn't have been too inhospitable.
Yeah, also a comment on the GC that you showed. You might want to bring that up. I think it was an interesting GC. I'm sure there are biomarkers in there that could be looked at. The thing that struck me was it doesn't really look like that mature a product. I'm looking at the carbon numbers here. For example, C20, C21, C22, C23, C24, C25. Well, there's sort of some funny business going on there, but it's certainly not a CPI of 1. That's a very strange distribution on the alkanes. It looks like it's overall maybe even predominance, which says it's not that mature a product.
Yeah, they claim that it's a slight odd even predominance, suggests that.
Well, that's interesting. I don't know what happened to C21 then.
Yeah, I don't know whether that's a product of the printing or, but it does look awful low compared to 20 and 22. And 24 is quite low, like you say.
Yeah, look, it looks like it goes from even to odd in there. It's almost you know, if you had a little imagination here, you could say it's maybe a little bit of a bimodal distribution with a heavier end that maybe maximizes around C25, and then lighter ends that mixed in with it. So maybe you could argue a dual source there. I don't know, but it would be interesting to get a sample of that and have a look at the stereoisomer ratios to get an idea of the maturity.
Yeah.
And in any case, if it isn't, if you would stick with an odd predominance, that says, hey, it's really not all that mature a product.
Well, it is right there in the immature rock. All right, you know, that's where they. So.
Well, it had to have migrated.
I would like to know where they got this, because this is from the Clarno, and
it's above the source.
The source rock is mid-Cretaceous, and this would be from the base of a section that's 9,000 feet thick, and yet they find it in the Clarno. I would have liked to see them run the GC on that, the one that got a lot of saturates or a lot of C15 plus extracted from it, and they didn't run a GC on that, which surprised me. This one, right?
Yeah. Well, by the way, that's not a flat baseline. That there are almost certainly biomarkers in there.
Oh, of course there is, but it's certainly not. It's certainly not the big ones that I'm used to. I mean, usually maybe I haven't been looking. I obviously haven't looked as many as you have, but it is not flat, but it is more flat than curved. It's relative. Would you agree with that, or do you think that's incorrect as well?
I'm willing to bet. You see, it does kind of go up there around C30, and that's probably where your terpenes and steranes are. I think you could probably, if you could get that sample, you'd have plenty of material to look at.
Right in here?
Yeah.
Yeah. Well, you want to go out to?
Hey, I'm so stir crazy from COVID-19. I'm willing to go almost anywhere, even the San Joaquin Valley.
Yeah, I hear you.